Hello and welcome back to another video. In this problem, we're asked to evaluate h of x is equal to tangent of x minus x over x cubed for the following x values. So what we have to do is just plug x into here and plug it into a calculator. 1, 0.5, 0.1, 0.05, 0.001, and 0.005. And what we're going to get when we plug these values in are numbers that are going to be approaching a certain value, and that is going to be the value of the limit. So plugging in, we have, I'm sorry, there shouldn't be an extra 0 there, I miscalculated. 0.577408, 0.370420, 0.334672, 0.333667, 0.333466, and 0.333336. So given these values, and again, there shouldn't be an extra 0 there, we can guess that the limit as x approaches 0 of this function h of x is equal to 0.33333 and so on, which is 1/3. So this is our estimation for B. But for C, guess h for smaller values of x until you reach a value of 0 for x. If we guess x with, let's say, 15 zeros, h of x, when you plug it into your calculator, is not going to give you a value that's very, very close to 1/3. It's going to give you a value of 0. Are we still confident that our guess in part B is correct? Well, no, we got a value that's very, very close to 0, and we plugged it in, and we didn't get 1/3, we got 0. So there's a couple things that could be going on here. One, you have to be careful about assuming that a pattern is going to hold just because it holds for certain numbers, right? If we look in the last problem, the whole purpose of this last problem was to say, okay, it looks like we're approaching 0 as we get smaller and smaller, but actually if you keep going smaller and smaller, a different pattern emerges and we approach this negative value. So we could have that, or we could also have an error in the actual calculating software. And it's kind of hard to know which one it's which from the information that we have right now. It talks about how in a later section, a method for evaluating this limit will be explained. However, if we graph the function in the viewing window that they want it, we can see that here we have, as x is approaching 0, we can see that it approaches 1/3. And of course, at 0 itself is undefined because we're dividing by x cubed. So dividing by 0 cubed would make it undefined because you can't divide by 0. However, if we zoom in on this point, everything looks normal until we see that there's a purple line going down. We're like, okay, that's weird. That doesn't look like the pattern that we saw earlier. And if we zoom in on this function, we see this odd shape down here that doesn't look anything like an actual function, but rather a drawing of something. And this is the distortions that we're talking about. And again, we can't really say from what we know right now what's causing this, but we can see that this is the same error or the same distortion as the textbook is calling it that caused our value of our limit to eventually go to 0.